The primary focus of Day 4 is to design the various components of the solution system. So corresponding to core process 4, which is design system components. So up to now, we have mostly been gathering the user requirements. On Day 4, we designed the system based on the user requirements. So in that sense, design activities can be considered a bridge. So design can be a complex process. So in our small project, we will limit our design examples to only a few models and techniques. So Day 4 activities include the following, which is design the database or schema and design the system's high-level structure. So database design flows directly from the class diagram that we have developed in, I think in Day 3. So this figure right here shows a tabular form for the database. This is for the supplier and then for the contact. And this figure here shows an enhanced class diagram. So as you can remember, we already created a class diagram before, but this one is an enhanced class diagram which provides the detail required to create the database schema. Designing the overall system structure or architecture is done using architectural configuration diagram. So this figure here shows the overall structure of the new system in terms of software components. So although the figure itself appears rather simple, so some important decisions have been involved in the development of this design. So first, note that the decision built for this application is to be a browser-based system that is designed for smartphones and tablets. So a different and very popular approach would have been to build specific smartphone or tablet applications. So these high-level design decisions will determine the detailed structure of the system. A browser-based system is structured and constructed differently than an application system that runs on a smartphone or tablet. So once we have an overall structure and approach for implementing the new system, we begin to drill down to the software design for the subsystem. So this figure here illustrates the design of the supplier information subsystem. So notice that this subsystem is further divided into layers, which is the view layer and a domain layer. So one of the advantages of partitioning the system into layers is it is much easier to build and maintain with this kind of structure given its modular format. So for example, the system will be browser-based, but different browsers require different techniques. So it is better not to get these complexities mixed with the basic program functionalities. That is why they are separated out into distinct layers. So the view layer includes two classes that represent what is seen on the user interface, the supplier view and the contact view, as well as the JavaScript functions. The domain layer includes two classes that interact with each other and with the database, the supplier and contact. So systems design is a rather complex endeavor. So you should understand that high-level architecture design should be done before low-level design and programming. It is important to have an overview of the entire system before building the detailed components, before doing some coding and testing. So these architecture diagrams that I've just shown you can be quite complex and difficult to understand. But for now, you should just be you just need to be aware that architectural design models do exist, but some are not shown in this lecture, and they provide an effective tool to think about and document the system in its entirety. So for day 5 activities, it focuses on two core processes, which is design system components and build, test, and integrate system. So basically, this focuses on the programming of the system. Though in this class, we're not going to perform any programming. So for this day, the activities for day 5 includes to create or to continue with design details and to program the subsystem component. Yes, the subsystem components. So as the programmer write the code, they also perform individual testing on the classes and functions they program. So this figure here illustrates some PHP code for the supplier view class. So for day 6 activities, so this is the final testing and deployment. Although, okay, so this figure right here shows the flowchart depicting the testing cycle. Start with to create test data, conduct tests, document errors and issues, fix errors if there are errors, then it will go back to conduct tests. If there are no errors, that it will end. So although there are many types of testing, we will mention only 2 types at this time. So overall system functional testing and user acceptance testing. Functional testing is usually a test of all user functions and is often done by the QA team or quality assurance team. User acceptance testing are similar in nature, but these are completed by the users who test both the correctness of the system and its fitness to accomplish the business requirements. So in some instances, the testing may be automated, which we call automated testing. In others, individuals may need to manually conduct the test, so we call that manual testing. So to recap of the first iteration, so as stated previously, this is the first 6-day iteration of a longer project. Using agile techniques and iterations within an overall project allows flexibility in defining and building a new system. In the 6-day project, the users have had major involvement during all days except day 4 and day 5. So a primary problem in developing a new system is that as the system progresses, new requirements are often identified. So this happens because the users and the project team learn more about how to solve the business needs. That is why Agile iterative projects are structured to handle these new requirements, often by adding another iteration to the overall project. As a final step in a current iteration, or perhaps as part of the planning process for the next iteration, there should be a review of the tasks completed and evaluated of the success of the current iteration. The lesson learned and issues to be carried forward create an environment of continual improvement and refinement. So because of this, iterative projects tend to improve and become more efficient during the life of the project. Also, during the last day of an iteration, it is common to do an introspection of the iteration to discuss what went well and what problems were encountered. So, because there are multiple iterations in an iterative SDLC, the project team has an opportunity to evaluate and improve their internal work processes. So, in this course, we focus on three major subject areas, which is system analysis, systems design, and project management. So, to a lesser extent, we will also cover systems implementation, testing, and deployment. Primarily, we will just focus on the first four core processes of SDLC.